And I would now like to introduce our speaker, Professor Hugh Griffiths of University College London, who will be speaking to us on the subject of Oliver Heaviside, electrical genius of the Victorian age. So over to you, Hugh.
Right, well, thank you very much for that introduction, and good evening, everyone. It's a real pleasure to have the chance to talk to you about heaviside. Um, First of all, may contain equations. Uh, Oliver Heaviside's contributions were substantially mathematical, and I will be using some equations to try and explain the things that he did. Equally, I hope it's comprehensible even to people without a mathematical background. So my first encounter with the name Heaviside was in my teens when I was learning about radio propagation, and I came across the Heaviside Layer named after him. Later, as an undergraduate student, I'd encountered the Heaviside step function, and about that time I'd also heard that he was what we might now call a bit of a weirdo. Yet it was much more recently that I came to know much about his work and his rather extraordinary personality in any detail, and to realize that he was very much a local man, born only a few hundred yards from where I live, which is in Rochester Square, actually. So there he is. Some facts and figures. His father was called Thomas Heaviside, and he was a wood engraver from Stockton-on-Tees, and he married Rachel Elizabeth West. They came to London in about 1849, and their youngest son, Oliver, was born on the 18th of May, 1950, at 55 King Street in Camden Town. Let's think a bit about what Camden must have been like in Victorian times. I think it would have been smoky and dirty. There'd be lots of horses and lots of horse dung. In fact, in 1858, in the summer, there was what was called the Great Stink, where the Thames became particularly polluted, and that prompted Joseph Bazalgette to build the sewage system that we now have. There's his birthplace in what was then called King Street. It's now called Plender Street. Heaviside's mother's sister, that's his aunt, I think, had married Sir Charles Wheatstone. You may have heard of him for something called the Wheatstone Bridge. And she'd actually been his cook. So this must have been an unusual marriage, particularly in Victorian times. And Wheatstone took a strong interest in his nephews and got them to learn French and German and Danish, and no doubt sowed the seeds of Heaviside's interest in wireless telegraphy. Oliver suffered from scarlet fever in his youth, and that left him partially deaf. And it's quite likely that this was a major factor in his rather solitary lifestyle. This is an interesting map that some of you may have seen before. It's from Booth's, it's called Life and Labour of the People in London, published in 1902. And it's a sort of colour-coded map showing the classes of the various people living there. So this is the area, I guess, just south of London, of Camden. You can see Regent's Park there. And the colour coding is such that yellow is upper and upper middle class, and black is described as vicious and semi-criminal. It's interesting to me, I think, that some of them are very close together, or maybe that's not so surprising. Anyway, Oliver wrote, I was born and lived 13 years in a very mean street in London, with the beer shop and baker and grocer and coffee shop right opposite, and the ragged school just around the corner. I won't read all of this out, but you can see that he didn't really like the place, wasn't really comfortable there. The sight of the boozing in the pub made me a teetotaler for life. And there is almost certainly the pub, the Parr's Head public house. That's no longer a pub, in fact, but that was built in 1861 when Oliver would have been about 11. He inherited some artistic ability from his father, and here are a couple of sketches that he had drawn. He was an above average student at school, scoring 1,140 marks out of 2,600 in the school leaving exam at the age of 15, and getting first place in natural sciences. He had some strong criticisms of the teaching methods of the time. So geometry was taught in a rather sort of old-fashioned way, even in those times, and he didn't really like that at all. And you can see it was a sad farce, though conducted by a conscientious, hard-working teacher. He left school at 16 and then pursued his studies at home. So he never went to university. And then at the age of 18, he took a job, which was the only proper job he ever had, with the Danish, Norwegian, English telegraph company, working in Newcastle and in Denmark. It's pretty clear that Wheatstone was instrumental in getting him this job. But during that time, he started to publish articles in the Philosophical magazine and elsewhere on various aspects of circuit and telegraph theory. Here's the blue plaque in Camden Street. I'm not sure about theorist of telecommunications. That seems a rather clumsy term to me, but see what you think by the end of the lecture. After 6 years, in 1874, he left this job and returned to live with his parents. 2 years later, the family moved to 3 St. Augustine's Road, which is a few hundred yards from Heaviside's birthplace. That house no longer exists. There were just some lock-up garages, but more recently it's been built over. Then in 1889, when Oliver would have been 49, the family moved to Paynton, which is near Torquay in the West Country. Oliver's brother Charles was a partner in a music business. Apparently Wheatstone was also interested in music and even invented something that was called the English concertina. So yes, those are the lock-up garages now being built over, as I said. There's the house that he lived in Torquay, called Homefield, and he was looked after by Miss Mary Way, who was the sister of his brother's wife. In 1916, she left. So from 1916 till his death in 1925, when he was 74, he lived entirely alone. This picture shows him as a young man, evidently a wiry, red-haired man. He was about 5'4" tall. And one description of him as a young man calls him very gentlemanly, always well-dressed, of slim build. Now, Heaviside's initial work was on telegraphy, what we would now call transmission lines, in the form of the cables laid under the oceans to carry, and at that time, just Morse code signals. The existing theory of the subject was due to Lord Kelvin and was based on thermal diffusion equations developed by the Frenchman Fourier. But that failed to account for a number of observations. In particular, it was noticed that there was a maximum signaling speed above which the Morse characters smeared into each other. That's now what we would call intersymbol interference or dispersion. So dispersion means that the different frequencies travel at different speeds, and hence a waveform becomes distorted. And that could even be asymmetrical. In other words, that a particular cable could carry information more rapidly in one direction than in the other. He wrote 3 papers in the Philosophical magazine, which gave a full theory accounting for these observed phenomena, and in particular showing that by appropriate choice of the parameters, it should be possible to have a dispersionless transmission line, which we all know and use these days. Perhaps the most obvious example of transmission line is the coaxial cable that connects your TV set to an antenna on the roof, if you do it that way these days. So a coaxial cable is a good example of a transmission line. So this is what he came up with. It's called the telegrapher's equation. So the symbols here, R and L and C, are the resistance and capacitance and inductance of the transmission line per unit length. And V is voltage, and X is distance, and T is time. So that's saying whenever the d2V by dx squared is the second derivative of voltage with respect to distance, dV by dt is the rate of change of voltage with time. And he showed that if this term here, L, tends to zero, sorry, if the second term here tends to zero, which you do by making L large, then it all reduces to that. And that's a simple equation whose solution is a wave propagating in either direction with a particular velocity, and it's independent of frequency. So he solved this issue of dispersion in the transmission line. He apparently liked to work late at night, and he liked to stoke up his fire so that the temperature was high. Hotter than hell, somebody called it. This is an example of a page from his notebook. So you can see lots of mathematical things scribbled there. And here's another example, which perhaps shows something of his sense of humor. And he did have quite a sense of humor. He had quite a major disagreement with the establishment in the form of William Preece, who was later Sir William Preece, the engineer-in-chief of the Post Office, fellow of the Royal Society and president of the IEE. So quite a pillar of the establishment. But he rather took pleasure in announcing his disdain for mathematicians in general and Heaviside in particular. So Heaviside asserts, somewhat impertinently, very much his own fault if Maxwell, who we'll come on to in a moment, is still fully to be appreciated. And also, Heaviside had written to the Electrician Journal suggesting the name Mach for the unit of inductance, named after Maxwell. And Preece's response was quite vicious. But we can see from this that Heaviside thought very highly of Maxwell's work. So this is what Heaviside said. Remember my first look at the great treatise of Maxwell's when I was a young man. Up to that time, there was not a single comprehensive theory, just a few scraps. And I read the preface in the last chapter, and several bits here and there. I saw that it was great, greater, and greatest, with prodigious possibilities in its power. That's quite something. Now, this is a couple of pages from Maxwell's treatise on electromagnetic theory. And you can see that the equations, well, first of all, there's an awful lot of them. You can also see perhaps that they use Gothic symbols, for example, here and here, which personally I found quite difficult to distinguish. So this is very difficult to read. So it's tempting to imagine that the formulation of Maxwell's equations that we're used to today was actually due to Maxwell himself, but that's not actually the case. Maxwell's formulation, as we see here, was in terms of potentials. And in fact, there were 20 rather than the 4 that we use now. Heaviside was convinced that the formulation should be in terms of fields. That's to say, the E field, the electric field, and H, the magnetic field. And Heaviside and the German Heinrich Hertz independently were responsible for the rather elegant and symmetrical formulation that we use today. But Hertz acknowledged, sorry, let me just get, yeah. Hertz acknowledged Maxwell's priority in all of this. Here is Maxwell, James Clerk Maxwell. You can see that he died rather young. So did Hertz, in fact. So Maxwell was born in Edinburgh, studied at Edinburgh and Cambridge, graduated in mathematics as the second wrangler. It is not recorded what happened to the first wrangler. Then he took chairs in Aberdeen, at King's College London for a time, then back to Cambridge. And this is the compact form of Maxwell's equations in vector notation that we all use these days. And you can see that they're much simpler and symmetrical as well. So this is what Heaviside wrote in trying to understand Maxwell's writings. Determined to master the book and set to work. I was very ignorant. I had no knowledge of mathematical analysis, having learned only school algebra and trigonometry, which I'd largely forgotten. And this is what Hertz had to say about Heaviside's work and this way of presenting Maxwell's equations in the most simple way. Hertz and Heaviside corresponded, exchanged letters, and you can see the results of which I have arrived, that's to say Hertz, are set forth in the present paper. Mr. Oliver Heaviside has been working in the same direction ever since 1885. And he removes the same symbols as myself, and the simplest form which these equations thereby attain is essentially the same as that which I arrive. Then he said, in this respect, then, Mr. Heaviside has the priority, which I think is a very gentlemanly thing to say. You probably wouldn't get that these days. Another of Heaviside's contributions, most original, was in something called operational calculus. So he'd devised a system of mathematics where the symbol P means to differentiate with respect to time, like that. And hence, P to the minus 1 means to integrate with respect to time. And so, in mathematical terms, this is P. P to the minus 1 means 1 over P. So integral from 0 to T like that. And then he introduced this symbol shown by a bold-face 1, which is the Heaviside step function. That's quite an easy thing to visualize. It's something that is 0 up until a particular time, and then there's a step, and thereafter it has a value of 1. So that allows him to define the integral in this form here. So that's equal to t for values of t greater or equal to 0, and 0 for values of time before that. And he was able to manipulate these operators algebraically and was quite happy to use things such as p to the half, or expand them as a series. That sounds a bit strange. What does p to the half mean? Surely you either differentiate something or you don't. But the point was that these worked. These did allow him to solve circuit problems very readily in a way that couldn't easily be done before. Here's a simple example. Again, may contain equations. This is a fairly simple problem in electrical circuit theory. So here we have a resistor and a capacitor, and at some particular time, t equals 0, we can apply a step of voltage here so that the voltage is 0 up until a particular time, and then there's a step to a particular value of voltage here. And at the instant that the voltage is applied, there's a current that flows through the resistor and charges up the capacitor exponentially until eventually the voltage on the capacitor reaches the voltage that's applied here. So he writes down the current that flows through the resistor to charge up the capacitor in this form here. One, the bold one, remember, being the step function. We can rearrange that a little bit like this, and then perform a series expansion of the terms in the bracket, 1 plus 1 over CPR to the minus 1. And that gives us a series of terms like this, times the step function. And then, using the result for 1 over P to the N being equal to this, we can substitute for each of these terms 1 over P, 1 over P squared, and so on, which gives us this. And we recognize the term in the square brackets there as the series expansion of the exponential function. So this is just telling us that the current that flows has this exponential form, which we can appreciate is the correct answer. So it works, and it's quite elegant. He wrote this up and tried to publish it in the Journal of the Royal Society. It was called On Operators in Physical Mathematics, Part 3. And Lord Rayleigh, who was the Secretary of the Royal Society, wrote back to Heaviside and said that they weren't going to publish it. They said that can I just check? Yes. Rayleigh wrote back to him and said, "I'm desired to return to you the thanks of the Royal Society for your paper, and to inform you that the Committee of Papers, not thinking it expedient to publish it at present, have directed that it should be deposited in the archives of the Society," which is where I think it still is. Heaviside didn't take that news particularly well, and he wrote to Fitzgerald, who was an Irish mathematician. "As regards my paper, I think I'd better drop it. I don't care to write for any medium where I'm not welcome. The way that the Royal Society behaves is extraordinary. They've lots of money to pay the cost of publication, and they deliberately refuse to use their opportunities. Such an impractical society." Fitzgerald replied and said, "I don't think it would be at all dignified or wise to take an extreme step because a referee differed from one as to the value of one's own papers. The best attitude is one of pity and regret that others should be so blind." So, yeah, those of us who do publish things in journals, just occasionally we do get reviewers, referees who say no, and you get rejection. So there it is. The bulk of Heaviside's writings are collected in 2 volumes entitled Electrical Papers, and 3 volumes entitled Electromagnetic Theory. When the first of these was to be produced, the publisher wrote to Heaviside to say that it was not usual to pay a fee to the author, but they would give him 100 copies free of charge. Heaviside wrote to Ambrose Fleming, who was the first professor of electrical engineering at University College London, asking whether this was indeed usually the case and whether he should insist on a fee. But Fleming's answer is not recorded, which is a shame. I've got a copy of the 3 volumes of Electromagnetic Theory, and it really is a remarkable book, not just for its context, but also its rather strange style. To give a couple of examples, there are successive paragraphs in part of the book that go by the titles the eruption of 4 pies, the origin and spread of the eruption, the cure of the disease by proper measure of the strength of sources. Remember, this is a book about electrical engineering. Obnoxious effects of the eruption, and a plea for the removal of the eruption by the radical cure. He had strong feelings about the rationalization of units, which is the issue he's talking about here. He said, there is, I believe, a growing body of opinion that the present system of electric and magnetic units is inconvenient in practice by reason of the occurrence of 4 pi as a factor in the specification of quantities which have no obvious relation with circles or spheres. And then another example, several appendices relate to electromagnetic waves in general, save the one on rational units. There is some progress to report. Of the 3 stages to salvation, 2 have been safely passed through, namely the awakening and the repentance. I'm not alone in thinking that the 3rd stage, the reformation, is bound to come. And this is a piece on the finite speed of light. Nowadays, I think we understand that it's not possible to travel faster than the speed of light. But here, Heaviside maintains that it should be possible. So he was quite a prickly character. Recognition did ultimately come. He was elected Fellow of the Royal Society in 1891. Of course, at that time, he was living down in Torquay. He was sent a formal notice asking him to come to London to be admitted, but he wanted nothing of it, and he wrote a little poem in his notebook. He said, "Yet one more thing before thou perfect be. Pay us £3, come up to town, and then admitted be. But if you won't be fellow, then don't." So he never came up to London to be admitted. Even so, he was a Fellow of the Royal Society. He was granted a civil list pension of £120 per annum, which would be about £15,000 a year in today's currency, in consideration of his work in connection with the theory of electricity. And that was supplemented by an additional £100 per annum in 1914 in recognition of the importance of his researches in the theory of high-speed telegraphy and long-distance telephony. So he was getting about £25,000 in today's money, which was comfortable. Just going back to electromagnetic theory, the 3 volumes, one of the more bizarre extracts is the paragraph that it goes right at the beginning of volume 3 of electromagnetic theory. The following story is true. There was a little boy and his father said, "Do try to be like other people, don't frown." And he tried and tried, but he could not. So his father beat him with a strap, and then he was eaten up by lions. Again, remember, this is a book on electric circuit theory. Really strange. In 1905, the University of Göttingen in Germany conferred on him an honorary doctorate, the PhD honoris causa. And the citation, which is freely translated from Latin, you can read it there. So it says he was given to a solitary life, but among the propagators of the Maxwellian science, easily the first. So yeah, recognition not just in the UK, but also from Germany as well. From 1916 till his death, he lived alone. His health was sometimes poor, and he clearly found looking after himself quite difficult. There's something that he wrote. "I made some jam the other day out of some apples that the boys had not stolen, and some blackberries which I could not eat. But I'm not fit for a cook, I forget. Then it all goes to cinder. Or if I boil an egg, I'm startled by a loud report. either I didn't put any water in or else it's all boiled away. From about 1918, he called himself the Worm and signed himself Oliver Heaviside, WORM in capital letters. He had a sort of friend during this period who was Dr. George Searle of the University of Cambridge. And Searle was a mathematician and experimental physicist. As a young man, he'd worked with J.J. Thomson on determining the velocity of electromagnetic waves, and he died in 1954. His obituary showed that his teaching at Cambridge was very highly regarded. It's suggested that the character of M.H.L. Gay in C.P. Snow's Strangers and Brothers series of novels may be based on Searle. This is Searle, a picture of him there. And Searle and his wife visited Heaviside on numerous occasions, and Searle was uniquely able to write what is without doubt the most faithful description of Heaviside's character. The manuscript was found by a chap called Ivor Catt and was published by him in 1987. Searle described Heaviside as impish, and it's true that he had quite a sense of humour. He sometimes liked to use his own version of Latin in his writings. So he wrote to Searle, Dr. Searle, te igita, to you therefore, I remit 10 of your English pounds in return for a loan. And Mary Way, who was his housekeeper, was described as mulia bestissima, the very best woman. Searle, in the book, was quite dismissive of Heaviside's use of Latin and indeed of Greek as well. But I think it's clear that he was just playing games with language. Another example of this is that he sometimes used an anagram of his name. Oh, he is a very devil, but it's not quite perfect. Mary Way, his housekeeper, had a lot to put up with. He referred to her as the baby, and if she went out and didn't return by the time Heaviside expected, she might find him in the garden with a lighted candle, looking for her dead body. In 1921, the IEE, Institution of Electrical Engineers, instituted its Faraday Medal and selected Heaviside as its first recipient. He was asked what form he thought the medal ought to take, and he replied, about 3 inches in diameter, 1 inch thick, and made of solid gold, please. But since it was out of the question for him to travel to London to receive the medal, the then president of the IEE, J.S. Highfield, went to Torquay to present him with it. Here's also an example of correspondence with the manager of the Torquay Gas Company, Oliver Heaviside, WORM. Then he called his house Wormfield. Please send 1 new gas meter of strong constitution to replace the present one, which is corroded both inside and out by the rotten gas with which you are supplying me. So this is what Highfield, the president of the IEE, wrote about going to present him with the medal. It was my duty as president to present the medal, and the duty was an interesting and pathetic one. Heaviside lived entirely alone in a pleasant house in Torquay, a house decaying from non-neglect. I called first by appointment and found him waiting in the weed-covered drive in an old dressing gown, armed with a broom, trying vainly to sweep up the fallen leaves. And then later, I saw him again in the August of 1922. He seemed greatly improved in health, and there's no doubt the interest taken and shown in him by his fellow workers of the institution had really cheered him. In fact, he seemed quite happy. Highfield also made arrangements to pay Heaviside's gas bill, which was substantial, and he sent the chief clerk of the IEE, Mr. Tree, to see Heaviside. And Heaviside wrote to Highfield Mr. Tree bought me a fine fat sole, which I cooked on Saturday on a special fire of Lipton's Thing boxes. To prevent it getting cold, I ate it right out of the pan on the fire, and having recovered taste, found it delicious. So that's good. At the beginning of this lecture, I mentioned the Heaviside Layer. So let me now come full circle. Marconi's experiments had led to the first transatlantic radio communication in 1901. That's from Poldhu in Cornwall to St. John's in Newfoundland. And the transmit equipment for that test was designed by Ambrose Fleming at University College, who I mentioned earlier on. There was some debate about the actual mechanism of propagation, because the curvature of the Earth means that the sea would present a significant obstacle to the direct transmission of waves over a path that long. But in 1902, Heaviside published this in an invited contribution to the 10th edition of the Encyclopedia Britannica. So he said, seawater has quite enough conductivity to make it behave as a conductor for Hertzian waves, and the same is true in a more imperfect manner of the Earth. The irregularities make confusion, no doubt, but the main waves are pulled round by the curvature of the Earth and do not jump off. And then the important bit, there is another consideration. There may possibly be a sufficiently conducting layer in the upper air. If so, the waves will, so to speak, catch onto it and be guided by the sea on one side and the upper layer on the other. So this is what we now call the ionosphere. The term ionosphere was actually proposed by Robert Watson Watt, who you may have heard of in the context of the development of radar. But that is actually what's happening. The signal is being reflected off this conducting layer, the ionosphere in the atmosphere, reflected round, so it's able to overcome the curvature of the Earth and reach the receiver. And nowadays, of course, that's well understood. But at this point, they were just sort of feeling and trying to develop the theory. In fact, Kennelly in America had made much the same suggestion more or less simultaneously. And there's some evidence that both were anticipated by a Scottish physicist called Balfour Stewart. But nevertheless, the Kennelly Heaviside Layer, or even just the Heaviside Layer, is pretty much universally recognized. Those of you who may have seen the musical Cats, which is based on a set of poems by T.S. Eliot, may remember that the big final number consists of Grisabella, the old cat, being taken up to the Heaviside Layer to be reborn. And you know, I think Oliver would rather have liked that. So let me finish there. I hope there's time for questions. Thank you for your attention.
Well, thank you very much, Hugh, for quite a complicated talk, but with plenty of other information fed in. Would anyone have any questions they would like to ask of
I can
Hugh?
see one hand up, yes.
Yes. Caroline Mara.
Hey, Hugh, thanks so much for that. That was a kind of like, oh my God, great talk. Very interesting.
Thank you.
I feel sorry for the Mulerimus bestissimus, I have to tell you. That woman there, what a lot of stuff she put up with. I'm sorry to ask you I'm sorry to be stupid. I'm not a mathematician of anything like his level, or I'm sure lots of the rest of the audience. But so when he was doing his mathematical things, was he just making that up theoretically, or did he have any kind of like practical stuff to go on. How did he make those numbers up? Was that just out of his head, or did he have practical stuff to start with? I'm sorry to ask this very stupid question.
No, not at all. Well, first of all, as I said, he never went to university. He left school at the age of 15. He was a good student at school, but certainly he never had the benefit of being taught these more advanced things in any formal way. So it's a good question to ask where that came from. He must have read a lot of self-study, and I think it came from that. So working through and understanding material from books. As I said, he was a rather solitary chap, so he wouldn't have sort of conversed with teachers or other people working on the same thing. There was some correspondence, of course. It's worth sort of asking ourselves the question, if we had somebody today who was really a bit of a weirdo, unconventional, without the normal sort of form of education, how would we respond to him or her? And you can even argue that it was because he didn't have a conventional technical upbringing that he was able to have these unusual and far-reaching ideas.
My question would, thank you very much. I have to say that I suspect that he would be what's now called as on the spectrum around neurodiversity. But anyway, the question I was really asking was, and I don't mean that in a bad way at all. I think that's how he managed to have such great ideas, because he was not thinking in straight lines or trammeled by standard methods of stuff. But was he really basing it on practical knowledge, or was it a theoretical mathematical thing that he was doing? So when you say, like, am I being clear about what I'm trying to say there?
I think so. When I showed the picture of the blue plaque, he was described as a theorist of communications. He did not solely do theoretical work. He did do experiments. There's a record somewhere of a disagreement with his father about the noxious smells that were coming from the batteries that he was using. So, yes, he did do practical work as well as theoretical, but it's the theoretical stuff that he's best known for, I think.
Thank you very much.
Does that help?
Yeah, definitely it does, because I was thinking, did he manage to do that theoretically, having worked from first principles with all the maths, or did he have some knowledge about the practicality of how this was going down cables and so on like that? It sounds like no, he didn't measure stuff going in and out of cables, did he?
No, he wouldn't have had access to that. I can see there was another question there in the chat about let's see. Get it.
Yes, someone has mentioned something down in chat. I missed it.
Do you want me to read it out, Ruth? It's from.
Yes, please.
Okay, I've got it. Yes.
We've got a nice message from Mark Aston saying, "Thanks, Hugh. Absolutely fascinating. Did Heaviside recognise or reference the early electrical telegraphical work of Francis Ronalds in neighbouring Islington, a generation or so earlier?" And then when you've finished with that one, John would just like to ask what his day job was, what his source of income was, so we can come back to that later. But first of all, do you think he was aware of Francis Ronalds?
I've not found any reference in any of the things that he wrote to Francis Ronalds. But yes, he can't have been far away in Islington. A generation or so earlier, so that would have placed him in the early 19th century or late 18th century. I don't know. I've not found any reference to Francis Ronalds in any of the things that I read about him. And the other question,
his day job, what was his? How did he afford it?
Well, he only really had paid employment for a year or two when he was working for the telegraph company in Scandinavia and the north of England. For all of the rest of the time, he lived off the money from his family. and ultimately he did get a pension, which was fairly generous, I think. But no, he didn't really have a day job. All of this was done off his own bat, which makes it all the more remarkable, I think.
He had a brother called, was it Eric, who was a telegraphic engineer of some description, post office engineer. Is that correct?
Yes, he certainly had brothers and I think sisters as well. I've not found a great deal about their work.
Uh-huh.
I think they helped support him, but
Right.
no, I don't think they helped him in his work at all.
Yes, Mark Aston will have been interested in this. What's his name? I've missed the name. Someone in Islington, because Mark is the local studies librarian in
Francis
Islington. So I
Ronalds,
guess
yeah,
Francis
yeah.
Ronald. So yes, I'm sure he would have been getting that sort of inquiry. So it's good to sort of join up information of that kind.
Thank you for that question. I will investigate that further, I think. Yes.
Okay. Has anyone else got any questions at all?
Is the Royal Society going to do anything else about him after they were not altogether always lovely to him, but sometimes nice? Then are they going to think about commemorating him in any other way?
They published a special issue of the Philosophical Transactions of the Royal Society about 10 years ago. Must have been about 10 years ago. And in fact, I wrote a paper that was published in that. So I think now, yes, he's properly recognized,
Yes.
including by the Royal Society, quite rightly, of course.
And what are you
Okay.
going to do next if you've plumbed Mr. Heaviside fully? What's your next plan, may I ask?
I'm sorry, I didn't hear that very well. There's some distortion.
What are you going to do next? Now you've exhausted Mr. Heaviside, then, or maybe you haven't, but I was thinking you probably have. What are you up to next? Says I nosily.
Well, I have my main research subject is radar, and I've written quite a few pieces about different kinds of radar. It's interesting that the very first radar was actually in Germany in 1904. There was an inventor called Christian Hulsmeyer who built a radar to try and detect objects on the Rhine River and prevent collisions in bad weather. And so he conceived and designed and built and patented this radar, but it wasn't really a commercial success. And so interest in radar sort of died away for a couple of decades and then came back in the 1920s, 1930s. So I also have a friend who gets me documents from the archives at Kew. In some cases, these were literally top secret, but now they're declassified, of course. And there's some marvelous stuff I've managed to get there, both about British radars and German ones, and including things like copies of minutes of meetings. And you might imagine that those are very dry and boring, but actually not a bit of it. They're fascinating. You can imagine the people in a smoke-filled room in the Air Ministry, and it would have been smoke-filled because they'd all smoke and have pipes and so on. And it's really fascinating to see who said what, who came up with particular ideas. Also, you might imagine that in those days, everyone was sort of on the same side and working smoothly and coherently together. Not a bit of it. They were arguing and really didn't always get on at all well with each other. I find that quite fascinating.
I've noticed a few messages coming up, including something from Bridget. Would you like to say something, Bridget, about what you've just mentioned down at the bottom?
Yeah, sorry, I might have missed if you mentioned this during the talk. I had to step away briefly, but the Royal Society have a Science in the Making project where they're digitizing a lot of their
Yeah,
archival materials. And in that, they've
yeah.
digitized like the handwritten papers of Oliver Heaviside, some of the referee
Okay.
reports of his papers, and also referee reports. It looks like that Heaviside wrote about other people's papers as well. So I've just put the link
Yeah.
to that search in the
That's
Zoom chat.
wonderful. Yeah, thank you very much. I wasn't aware of that, and I shall certainly pursue that because that's fascinating. Yes.
Yeah, I think they just launched it quite recently, and I mean it's a massive treasure trove of stuff that they've digitized.
Yeah. Yeah. Oh, thank you. That's really interesting.
And someone else with a message. Andrew Jones.
Yes. Have you heard of my Uncle Phil, who is one
I'm
of the
sorry,
top,
I don't think I have.
who is one of the top? My father was made to go in the rag trade at 14, and they tried
Oh,
the
yeah.
same trick with my Uncle Phil, who then went on, and they had a bit more money. So, and the my grandmother, the headmaster of the school, said he was very talented. He
Mm.
he worked for Marconi's, and then got headhunted by
Yeah.
Boeing's, and he invented flying by
Yeah.
wire, they had um, Jones's Radar Village in Seattle, and he was one of their. He did a lot of stuff for NASA as well, but he
Yeah.
invented flying by wire, which is what all these
Wow.
aircraft fly on.
Yes, indeed. Yes.
He's
I
one
didn't
of the
know about that.
He's
That's
one of the top radar. He's somebody.
yeah.
Uh, somebody around here has just done a lot of research on a lady called Lee Miller, who was a photographer in the first one of the first people to go into the concentration camps to photograph them. But I've been
Yeah.
trying to think
Yeah.
about researching my uncle because his story needs telling. Because a lot, and
Yeah.
he met my auntie Leslie at the physical laboratories in in Teddington, and she came from Grimsby.
Hmm.
She was the baby of a trawler family and
Hmm.
he was always going up there putting stuff into, I think, into trawlers. He did a lot of secret work and that. But I was going to
Yeah.
contact the
My word.
He's passed away now, but last time he came over on business, you could tell how senior he was because he was deputising for the president of Boeing's. And an American company, the president of the company is more important than the managing director. But he's
Yeah.
somebody you ought to really
Yeah.
get to Boeing's and have a look at because he's the Seaford Museum are having a talk, and they've just written in their latest about a chap called Stephen Montford that worked for Marconi's, and I think he might have been a mentor of my uncle. And if my grandfather had his
Yeah.
way, none of this would have
I had
happened. But he's one of the top radar people for
I,
Boeing's. You might be, if you're into radar, having a look into him.
yeah, I had a PhD student who works for Boeing. Um
Oh, well,
and so he was
he
doing an
probably would have
external
known Phil.
PhD. His work
My,
was in the US, and he
my
well,
cousin
that's what
Nicky
I'm
is
going to
just
ask him. Yes.
my cousin Nicky has just retired from. He also worked for Boeing. He said he's very glad he retired from Boeing before these aircraft, these 337s started dropping from the sky.
Oh, absolutely. Yes. Yes.
Yeah, my uncle has passed away now, but I
Absolutely.
would think if
Yes.
you've got
Yeah.
somebody from Boeing, they will definitely
Okay.
know of Phil.
Yeah.
Well, it seems as if we've
I will,
got some useful contacts for doing various other bits of research, or people are interested
Yeah.
in history of science. So I think maybe have we exhausted everything for this evening, or would you like to mention maybe? I don't think, I'm not sure if anyone in Paynton or Torbay is doing anything or is commemorating it, though I think there is some sort of choral group that meets from time to time down there and to celebrate
yeah.
Heaviside.
They
Yes.
they did erect a blue plaque at the house where he used to live.
Yes.
Um, but that's rather fallen into disrepair recently, I think. which is sad. But yes, it is true that he has 2 blue plaques to his name, and that's quite an achievement.
Yes, indeed. Anyway, all that remains to do is to thank you very much, Hugh, for your interesting talk and to stimulate us in various ways, whether through your use of equations, which maybe a lot of people didn't understand, or maybe, or also the various interesting, strange things about Heaviside. And I think we can sympathise with him for having to deal with such a miserable lot of people throughout his life. So thank you very much.
I can assure you they're still around because I'm autistic and I get the same problem because being autistic. I can't add up. I've got maths dyslexia, but people still oddities. They still don't like the look of them. It's nothing new.
Anyway, thank you very much.
Well, thank you for your attention and thank you for the questions. You've given me some good ideas there, and I shall pursue them. Thank you.